Sachin sir, hello. Good afternoon to all the students. Up till now, we have covered all the basic things related to gear. Now today, we will see the expression beam strength of gear tooth. Therefore, you are knowing that whatever spur gear teeth are there, they can be considered as cantilever beam with one end fixed and other end is free, and tangential load is uniformly distributed along the entire face width. Therefore, in the diagram, it has been shown that width at the base is equal to B. Therefore, T is equal to thickness of the tooth and H is equal to height of the tooth. And this PT is the tangential load which is uniformly distributed along the entire face width. Therefore, the analysis of bending stresses in gear tooth was done by Wilfred Lewis in his paper The Investigation of the Strength of Gear Tooth, submitted at the Engineers Club of Philadelphia in 1892. Even today, the Lewis equation is considered as the basic equation in the design of gears. In the Lewis analysis, the gear tooth is treated as a cantilever beam. The tangential component Pt causes the bending moment about the base of the tooth. Therefore, whatever it has been written here, it is expressed in terms of figure here. Therefore, because of this tangential load Pt, bending moment will be there with distance h at the base. Therefore, all the students should draw the diagram and write down this. We will wait for 5 minutes. Hello. I think you have drawn the figure and you have written it. Next, the Lewis equation is based on the following assumptions. The effect of the radial component PR, which induces compressive stresses, is neglected. Second, it is assumed that the tangential component PT is uniformly distributed over the face width of the gear. This is possible when the gears are rigid and accurately machined. The effect of stress concentration is neglected. It is assumed that at any time only one pair of teeth is in contact and takes the total load. Therefore, write down these assumptions in your notebook. We will wait for 5 minutes. Hello, I think you have written this. Now next, it is observed that the cross section of the tooth varies from the free end to the fixed end. Therefore, a parabola is constructed within the tooth profile and shown by a dotted line in figure. The advantage of parabolic outline is that it is a beam of uniform strength. For this beam, the stress at any cross section is uniform or same. The weakest section of the gear tooth is at the section XX, where the parabola is tangent to the tooth profile. Therefore, whatever it has been written here, it is expressed in figure here. Therefore, this is our original gear tooth. Now, in this gear tooth, we have constructed a parabola which is tangential at the base of the tooth. See that this dotted line indicates parabola, and at this parabola, that is at the vertex of the parabola, this tangential load or tangential force Pt is acting at a distance h from the section xx. T is the thickness of the tooth and B is the face width of the tooth. Therefore, if you will take section XX, it will look like a rectangle having one side as T and other side as B. Therefore, draw this diagram and write down this. Hello. I think you have written this. Now next, again we have drawn the diagram here so that while writing the equations it will be more clear to you. Therefore, at the section XX, bending moment MB is equal to PT into H. See that this is the section XX. Therefore, at the section XX, we have to take the moment. Now, moment you are knowing, moment is nothing but force into perpendicular distance. Therefore, force is nothing but PT and perpendicular distance is H. Therefore, MB is equal to PT into H. Now, since cross section at the section XX is rectangular, therefore, we have to find out its moment of inertia and distance of neutral axis from the base. Therefore, its moment of inertia I is equal to Bt cube by 12 and distance of neutral axis from the base y is equal to T by 2. Therefore, we are knowing the bending equation sigma b upon y is equal to mb upon I. Therefore, where sigma b is known as bending stresses, sigma b is known as bending stresses. Therefore, sigma b is equal to mb into y divided by I. Therefore, we have to substitute the above values. Value of mb pt into h into t by 2 divided by bt cube by 12. Therefore, write down this. Hello. I think you have written this. Now, next step, rearranging the terms. We are getting PT or tangential load is equal to B into sigma B into T square upon 6H. Now, multiplying the numerator and denominator of the right hand side by M, where M is equal to module. Therefore, PT is equal to MB sigma B into T square upon 6HM. Now, defining a factor Y. Therefore, Y is equal to T square upon 6HM. Therefore, tangential load PT is equal to MB sigma B into Y. Therefore, in the above equation, Y is called the Lewis form factor, and above equation gives the relationship between the tangential force Pt and the corresponding bending stress sigma b. Therefore, write down this. Hello. I think you have written the steps. Now next, when the tangential force is increased, the stress also increases. When the stress reaches the permissible magnitude of bending stresses, the corresponding force Pt is called the beam strength. Therefore, the beam strength Sb is the maximum value of the tangential force that the tooth can transmit without bending failure. Therefore, replacing Pt by Sb in the above equation, we get Sb is equal to, Sb is nothing but beam strength, is equal to mb sigma b into y, where Sb is equal to beam strength of gear in Newton, sigma b is equal to permissible bending stress in Newton per mm square, y is equal to Lewis form factor, m is equal to module. Above equation is also known as Lewis equation. Therefore, write down this. I think you have written the values of the Davis form factor Y for 20-degree full depth involved system are given in following table 3. Therefore, table 3 indicates Lewis form factor Y for 20-degree full depth involved system. Now in this table there are two columns. Z is nothing but number of teeth and Y is nothing but Lewis form factor. Therefore, for 15 number of teeth, Lewis form factor is 0.289. Similarly, for 16, 0.295. For 18, 0.308. For 20, 0.320. For 21, 0.326. Like this, for different number of teeth, Lewis form factor is given. For 40 number of teeth, Lewis form factor is 0.389. For 50 number of teeth, Lewis form factor is 0.408. For 70 number of teeth, 0.429. For 100 number of teeth, 0.446. And for the rack, which is having infinite pitch circle diameter, Lewis form factor is 0.484. Therefore, these are the values of the Lewis form factor Y for different number of teeth. While solving the problem, this Lewis form factor is provided to you. Therefore, there is no need to remember the table. Now, in order to avoid the breakage of gear tooth due to bending, the beam strength should be more than the effective load or effective force between the meshing teeth. Therefore, SB should be greater than equal to P effective. In the design of gears, it is required to decide the weaker between the pinion and gear. Therefore, rewriting the Lewis equation, SB is equal to MB sigma B into Y. It is observed that M and B, that is module and face width, are same for pinion as well as for gear. When different materials are used for pinion and gear, that is for pinion cast iron is used and for gear if steel material is used. Therefore, different metals are used for the construction of pinion and gear. At that time, we have to take into consideration product of sigma B into Y, which decides between weaker between pinion and gear. The Lewis form factor Y is always less for a pinion as compared to gear, because if you observe the table, Lewis form factor Y depends upon number of teeth. Therefore, for pinion, always there are less number of teeth. Therefore, Lewis form factor is less for pinion as compared to gear. Therefore, when the same material is used for the pinion and gear, the pinion is always weaker than the gear. Therefore, while designing this factor, we have to take into consideration. Sometimes in the problem, they are saying that cast iron material is used for the gear and steel material is used for the pinion. At that time, immediately you have to understand that we have to calculate the product sigma B into Y, and the value for which sigma B into Y is minimum. We have to design that pinion or gear depending upon the value of sigma B into Y. Therefore, write down this and we will stop here. Write your roll numbers in the chat box. Thank you very much.